Okay, this again, this particular problem is a reading off your graph, which I think that you should be used to by now. If you're looking off the graph, they just want you to find the y values. They gave you the x values by just looking off the graph. So you go over to -3, and you go down to the y value. What's the y value? -4. Easy. Okay, -1, what do we get? 0, because it crosses the x-axis. That's where the y values are 0. 2. At x equals 2, it looks like it's at, let's see. At x equals 2, it looks like it's 2, right? And at x equals 3? Nice. Okay, this figure, I know that you can't draw, you can maybe draw these actually on a piece of paper, but this question is whether this graph defines a function. And what you may have learned what did you learn in the past? What is the definition of a function when you look at the graph? Has to pass what?
I know that it's not across.
That's right. In terms of biology, a function is when you're running an experiment, you only get one outcome from the experiment. So let's suppose you're looking at a petri dish and you're counting cells in there. I know you can't count the cells, but you're weighing them. You're not going to get 2 different measurements at one point, right? So, but this is giving you 2 different measurements. At this x equals 2, you're getting a y value of around -6 and a positive value of around. You have 2 answers at one time point. That's not heard of. A function should only have one answer at one time point. So that's why we say it fails the vertical line test, because you've got 2 y values for one time point. That doesn't make any sense, right? So this is no. Vertical line passed in more than one point. Failed. The formal definition, which I don't think they have it in the book, but it basically is that there should not be 2 y values for one x value. So if x1 is equal to x2, if the time values are equal, the y values must be also equal. So that's the formal definition. But I didn't see any problems on Webassign where they ask you the formal definition. So I think all they want you to know is that this is the vertical line test. That is a circle a function? Unit circle, a first question almost every quiz and exam that you've had so far. Is it a function? No, because if you drew a vertical line through, it would pass in more than one point. I do know you're texting. I'm the master texter. I wasn't talking to you, but I'll text you a message right now. What's your number? Actually, who did I call in here during class? I called someone in class, and they picked up their phone. And they picked up their phone. I was like, "What are you doing on the phone during class?" That was pretty funny. Were you laughing?
Yeah.
I just thought it'd be easier to talk to you. Okay, so this one, it can be made, these kind of problems can be made very easy on your calculator, but you got to beware, okay? I don't know if you have a button like this, but let me see if, do you have a button with abs, like absolute value, on your calculator? The graphing calculator online had an absolute value thing, and it made a parenthesis, just like there, like this. You have something like that? Oh, that's so cool. That is so cool. Because absolute value questions, this is something whoever's taking Calc 1, and they should take it next semester. They should. Whoever's taking Calc 1 should know that that button's on there, because there's so many absolute value questions. Tons of absolute value. Make a little mental note that you're not going to forget this button. So you can just tell it to graph. Found it? Very useful for you for Calc 1. Very useful. See, if you wait, you're going to forget who I am. You're going to take it from somebody else. You're not going to remember any of that. You're going to have that edge. And you're not your friends. You might be smarter.
Maybe.
Come on, say it with confidence. You're smarter. Let me tell you the warning with absolute values. Absolute value signs are supposed to make some kind of, they're supposed to stay above the x-axis. So I don't have the full picture. Now I know on your calculator you have a zoom out, right? So all I did is I hit the zoom out button on this calculator, and this is what I got. So you didn't get the full picture. So just as a word of caution, when you're graphing anything that's not a line and you see a line, beware. Do a zoom out and make sure you got the whole graph. So step 1, graph on calculator. Step 2, zoom out. So you can see the whole thing. Don't forget to do that. I saw you this morning and you totally blew me off by the recreation center. Before coffee, like around 7:30. One of these days I'm going to jump out and scare you. And you were smiling at Dr. Hallaby from biology, and I thought she likes the biology professors better than she likes her math professors. And I got jealous. Okay, so here's what they want to know. There's this little thing. They want to know where this function's decreasing, where it's constant, and where it's increasing. If you have the graph on your calculator, you can answer all those things. Where is it constant? Well, from minus infinity up to this value right here, which looks like it's -6. Is it? On the trace button you found it? It's -6?
no,
I don't know. It's like -4, -5, -6. It looks like it's around -6, right?
-5.1.
-5.1? So I'm going to bet you, since that's a calculator, it's -5. So decreasing from minus infinity to -5. Oh, wait, constant. Nice eraser button. So it's constant from minus infinity to -5. And then it's constant again. Constant means it's a horizontal line, right? Constant from here to here. And it looks like it's, again, trace button would look like 5 again, from here to here. Is it 5 or 6? Right here, where it's flat again, where it starts being flat again. Is it 6? 6 to infinity. We can get this by hand, but why should we? We have it. We have the answer here.
And zooming out shows you the full graph. So it's like, you know it's coming from negative infinity.
Right. So there's nothing wrong. I can plug in as large values as I want into for the x's. There's nothing wrong with it. There's no square roots or anything, right? So this graph extends. If I zoomed out even further, it would just keep going, right? You agree? Do one more zoom out and see if it changes. It may change.
I changed the window.
Change the window.
That's why I added it. Change the window to
No, I see the graph. How'd you get to negative infinity to -5?
You got a good point. We should actually see. Let me see. If we zoom out one more time, is it going to do something different? Zoom out one more time. Can you zoom out one more time and see if you get something different? Come on. I might have missed something. I'm using decimals because it's better. Let's see. So it equals absolute value of x minus 6 plus, or was it minus x, absolute value of x plus 5? Yeah, I get it. If you keep zooming out, nah, it just keeps going. Keep zooming out. Take one more step back. It'll just keep going in both directions. But you've got a really good point. You know, if you're not going to do this by hand with all the calculations and you're going to do it like this, you got to be right. Because if you're not right, then the person will know that you just looked on the calculator and you might not have an idea. But you do, actually, you do have a good idea because you're looking at this entire graph. So yes, zoom out a couple times, not just once, to make sure that this is the full graph. So I've got these two pieces. Decreasing. Decreasing means the graph is going down. It's decreasing in between here and here. This would be -5 and this would be 6. And where is it increasing? Well, nowhere. It's not increasing anywhere. Yep. So I don't know what they want us to put in there. It's not increasing. It's only going, it's constant and it goes down and it's constant. Unless, let me see.
We're gonna have to put that mu symbol.
Which mu symbol?
That constant, like if from negative to infinity.
Yeah, that's minus infinity, yeah. You have to because it's Webassign, or else you can't check your answer on there, right? You could write it out on words on the test. You could say it's constant from way out there to -5. You could say it however you want. Nowhere. So that one makes sense? It's easy on the calculator. And you can use your trace button just to check. You should see that it's complete, the y values are all constant, and then it's going down, and then it's all constant again. All right, so I'm going to save the next piece and then